Welcome back everybody, 18F4550 videos here, and in this video we're going to perform traffic cone detection. So to whet everybody's appetite, let's take a look at the project we'll have completed at the end of the video today. So let's see if we go Visual Studio 2013 Progs, Visual Basic, and traffic cone detection, and open the solution file, and then we'll go ahead and run it. And let's move this over to the side a little bit here. So we have some sample images here, 13 to be specific. So in each image we're able to find the cone successfully. So what we'll do is we'll draw a yellow that ends up being a convex hull around the found cone. We'll get to that in more detail later. And a green dot at the center of mass of the convex hull where the found cone is. And of course you probably noticed we show how many cones were found at the bottom of the screen here. So one in that image. One in that image, we're able to successfully screen out all the orange traffic barrels and sign and so on the right. Again, we'll get to the details of that later. And we can detect multiple cones as well. In this image there's 6. And in this image there's 1. And in this image there's 2. And we'll just kind of cycle through all the images here. 3. And notice being in the shade doesn't disturb our detection. And in this case we have 4. We're not going to count objects that aren't pointing upward, which is why the cone that the construction worker here is holding isn't counted, but the 4 that are upright are counted successfully. And there's just 1 in this scene, and I believe 4 in this next scene. There we go. And this next one has 6 sort of all clustered together in here next to each other. And then 1 here, and in our final image there is also 1. And then just as with the license plate detection program in the previous video, we have a show steps button here. So if we check that, then we can take a look at our steps. So there's the original image, hue saturation value image, threshold low, high. Again, I'll explain all this later. Image threshold, smooth, canny edges, contours, convex holes of the contours, convex holes that have a certain number of points. And then we eliminate all the convex holes that aren't pointing up. Again, I'll get to that in more detail later. And then there's the final convex hull, and then we simply draw that on the original image. So before we go any further today, I'm going to quickly cover the prerequisites for this video. Actually, there's only one. So if we close out of here, close out of here, close out of here, and if we go to my YouTube channel, so YouTube, and just a second while it comes up here, there we go, 18F4550 videos. And that'll jump you to here, choose that, and then choose videos. And the only prerequisite for today that I would recommend is OpenCV 2.4.11 Windows 7 Installation Guide Part 3, which covers the installation and configuration of MGooCV, which is essentially a huge wrapper library so that you can call OpenCV functions from within the .NET Visual Studio environment. So in this installation guide we had one example program that performed some relatively basic object recognition and tracking, and of course today's program is in a sense an extension of that. So definitely check this video out if you have not already. And the next thing we'll take a look at are the GitHub repository contents for this project. Type GitHub and then microcontrollers and more, all one word. That's the name of my GitHub site, so microcontrollers and more, all one word. There we go, and it pops right up. Microcontrollers and more GitHub, there we go, and then go to here and then repositories, and you'll probably want to go ahead and bookmark this section if you have not already, and then choose this repository here, traffic cone detection Visual Basic. By the way, for anybody that hasn't done the installation and configuration for MGooCV, there is a repository for that as well. It's here, OpenCV 2.4.11 Windows Installation Guide, and that has all 4 parts of the installation guide in it. But if you're interested in the MGooCV specific parts, you want to follow installation cheat sheet 3 here, MGooCV 2.4.10 for Visual Basic .NET and C#. But anyhow, getting back to today's repository, so if we go into traffic cone detection Visual Basic, there's 2 directories and then 2 additional files. So the README that's just a README. You see that here. Basically, that just links to the video that you're watching now, or it will when this video is done. Form main.vb is where the entire program is. I'll get to that momentarily. Images, these are the 13 images that we looked at when we tested the program just a moment ago. These are the same version, same size, same everything of those images that we looked at just a moment ago. Here are some slides that I made to explain some of the things that we're going to go over today. So let's go ahead and save these to our desktop, and we'll go to Raw, Save As, make sure it's on the desktop. That's good. And X out of that. Okay, we can go back one. Steps.png, this is just a graphic, so save picture as, desktop, save, and let's see what's next. Form design, once again, save picture as, make sure we're on desktop, save, and one more here, save picture as, desktop, and save. Okay, so let's take a look at each of those steps and form design. So form design is pretty self-explanatory. This is just the form for the program that we demoed a moment ago and that we're going to build throughout the rest of the video today. It's a pretty simple form, very similar to the last video. We have a button to open the file, a label to show what file was opened, a checkbox optionally to show the steps, and then we have an area here to show the image, and then we have the text info box so we can print text to the user, and then we have not on the form but at the bottom here we have the open file dialog that allows us to open the file. That's pretty straightforward. And let's take a look at steps next, and this is the order of the function calls that we're going to go through today. I'm going to quickly pause and change to the smaller cursor, just a moment here. Okay, recording with the smaller cursor here so I don't block the text as I'm going. So, and we already took a quick look at the show steps button, but this essentially just kind of steps us through that logic and mentions which functions we're going to call and how we're going to go about it. So we start with image original, and then we convert to HSV. For those not familiar with HSV, that's short for hue, saturation, and value. And I'll bring up the Wikipedia page on it very quickly here. Hue, saturation, and value is often used, HSV color space, is often used in imaging to search because it due to how it deals with luminance and other things, it often works better to filter on color within the HSV color space than within red, green, blue. So one issue you do run into with the HSV color space here is that the hue essentially is represented as 360 degrees around, and from 0 degrees to 360 where it wraps around is where the red area is, unfortunately. So if you're searching for red, you have to search essentially for this threshold on that, then you have to search for this threshold on that, and then combine the two threshold images. So that's what we're going to do today. One other thing that I also should mention as long as we're here is you'll notice that HSV, we generally think of hue as going around in a circle, in other words from 0 to 360 degrees, but of course in an 8-bit variable you can't go higher than from 0 to 255 even if you have it unsigned. So how do we go up to 360? Well, we don't. What OpenCV does is it actually halves the number. So for example, and also it stops one before 360. So in other words, if you were to go from 0 to 359 degrees but then half that, so in OpenCV, the hue component goes from 0 to 179. So in other words, if you were looking for a hue of 180, like in between regular blue and light blue about here, you would, in OpenCV, you would actually look for 90, right, half that amount. So getting back to our chart here, so we have our HSV image, and then we're going to call InRange twice on that, once to get that low threshold of red, and then once to get the high threshold of red. And then we perform a logical OR to combine these two into image thresh. Then we erode, dilate, and smooth Gaussian, and that gives us image threshold smoothed. And then we call canny on that to get image canny, which of course is the canny edges. And then we call on the canny edges image, we call fine contours and approx poly, and that gets us image contours. And then we call convex hull. By the way, these the blue circles here, those are images by the name that they're labeled when the show steps checkbox is checked. So hopefully that'll make it easy to follow this through to the program if you choose to do that later on. So once we have our contours, then we call for each contour in our list of contours, we call get convex hull, and that gets us our convex hull for each contour, and then also gets us our image all convex hulls. Now for those not familiar with a convex hull, essentially what that is is, well, I'll explain it more in the next slide. It'll be easier with some pictures to explain it with. Once we have our convex hull, then we check and make sure that the number of points in the convex hull is at least 3 and not more than 10. If so, we throw the image out at that point, or that convex hull, I should say. So that gets us to image convex hulls 3 to 10. And then we check if that convex hull is pointing up. I mentioned that in the beginning of the video, the construction worker was holding that cone, so the one cone wasn't pointing up, so that wasn't detected. You're going to see when we take a look at show steps, there's going to be multiple other artifacts in most images that will be convex hulls that won't be pointing up, and it's pretty much a necessity to use whether the shape is pointing up or not to screen out the things that aren't traffic cones. So unfortunately that's sort of a necessity to miss the traffic cone that that construction worker was holding, so it wasn't pointed up, but it's a worthwhile trade-off. Again, I'll explain in the next document a little bit more clearly if it's not clear at this moment. That gets us to image traffic cones. So in other words, if we get to this point, if we pass all these ifs here, then now we're satisfied that's a traffic cone. And as those of you who have worked with defined contours, a function will know sometimes it'll detect two contours sort of almost right on top of each other, or one within another. As far as dealing with the one within another case, something that I should mention is when we called find contours back here, we're going to find only external contours. So nested contours are not a concern for us. However, sometimes the find contours function will find two contours that really in reality are the same object, but it was detected as two separate contours that almost overlap each other. So then we call remove inner overlapping cones so that we don't count the same cone twice should that occur, and that gives us image traffic cones with overlaps removed, which is the end of our find traffic cones function. And there we have it. After that, it's just a matter of updating the main form. So this next document essentially is the same thing as the steps document that we just took a look at, but it has images accompanying it, and hopefully that'll make this a little bit easier to follow. So if we go to the beginning here, so we start out with image original, and then we convert to HSV. That gives us image HSV. And then we call inRange to get the low and high end of the red detection of the HSV color range, and then we logical OR these two images together, and that gives us image thresh. And then we erode, dilate, and smooth Gaussian, and that gives us image thresh smoothed. And then we find canny edges on that, and that gets us image canny. And then we call find contours and approx poly, and you're going to find in the program we pass in a value of 8 into approx poly. The reason for that is that we don't need every particular detail of the contour, we just need sort of more or less an overall outline shape of each object. And so that'll give us image contours. And here's what I was mentioning earlier. When we go from image contours to we call get convex hull and then image convex hulls, here's a convex hull of this contour. What's the difference? Well, what a convex hull does is we take the points. So for example, in this cone here there appear to be 1, 2, 3, 4, 5, 6 points if I'm seeing all those correctly. The image isn't quite zoomed in enough to be 100% confident of that, but let's just say it's 6. So we can see we have this one side here that's concave, and the nature of the way traffic cones are, the base sometimes will be red, sometimes will be black, depending on angle, illumination, other variables. The base may turn out to be elaborate in shape, and therefore if we consider the base in detail, then that may obscure the overall shape of the cone. So what we do is we call get convex hull, and that essentially takes the contour again but without the concave part. So in this case, for example, this side here, what get convex hull will do is it's going to draw a line from this top left point to the very top one, directly down to this bottom right one, then to this one, then to this one, eliminating that concave portion. So that gives us this shape here. You'll notice for many of these others it doesn't have too dramatic of an effect. For example, for a 2D line there isn't really a concave portion of that, so those are going to come straight through to this image just as they were before. Same thing with this big square here, or square turn, so it's a kind of a diamond in shape. So once we get to image convex hulls, obviously this is a traffic cone we'd like to detect, so how do we eliminate all this noise? Well, the first thing we can do is we can check if for each convex hull, if it has at least 3 points but less than 10, and very few convex hulls are going to have more than 10 points. Occasionally you might get a really elaborate object in your image, but much more commonly is the case where convex hull dot total isn't as many as 3. So for example, for these lines here that just have a point on either side, we can throw those out with that. And so that gets us to this image. So now how do we get rid of this other noise? Well, here's where we're going to use convex hulls as pointing up. And this convex hull here, you can clearly see has a conical oriented shape, and it's pointing up. Whereas this here is pointed left, that's pointed right, that's pointed down, that's pointed, I don't know if you'd say left or right, but it's definitely not pointing up. And then the square overall doesn't really point one particular direction or the other. And that's going to get us to our traffic cone only. So in just a moment here, we'll take a look at a slide I made to explain a little bit of additional detail on how we do the function convex hull is pointing up, but let's hold off on that for just another moment. So that gets us to image traffic cones, and then we're going to remove the inner overlapping cones if there are any. In this image, there's not, there's only the one, but just in case there was more than one traffic cone overlapping that one. Then we get to image traffic cones with overlaps removed, and then we also draw this green dot at the center of mass of the traffic cone, and then at that point it's just a matter of updating our main form, and there we are. And this next document that we're going to take a look at here, this is how can we tell if a convex hull, in other words a possible traffic cone, is pointing up. So I've got 3 examples here, but let's first take a look at the sort of general rules that the function is going to employ. So first we're going to check the aspect ratio. For those not familiar with that, that's width divided by height. So if the object is taller than it is wide, that will be less than 1. So we're going to look for an aspect ratio that at the most is 0.8. If it's any more than that, it's too proportionally wide compared to its height, so it's an object generally speaking that will either be pointing left or right. So once we've applied the checked aspect ratio test for any of the convex hulls that pass that, the second check that we're going to apply is we're going to check if every point above the vertical center is within the width of the widest points below the vertical center. That's a lot of verbiage there, so I drew out these examples to try and explain it a little better. So let's take this first example here. So these blue dots, let's say, are points in our convex hull. So we have 1, 2, 3, 4, 5, 6, 7, 8 points defining our convex hull here. So what we can do is take the absolute highest one, which would be this one, and the absolute lowest one, which would be this one, and then we can take the y location between those two. So that effectively gives us this horizontal line here that I've labeled vertical center. And then what we can do is we can make a list of all of the points that are above the vertical center in our convex hull and all the points that are below. So these 4 would be in the list above, these 4 would be in the list below. Then the next thing that we are going to do is we're going to go through the list of points below the vertical center, and we're going to pick out the leftmost and rightmost points. So in other words, the lowest x value and the highest x value. And once we have those values, we can sort of think of those as vertical lines that I've drawn on here. So then the next thing we're going to do is we're going to check and make sure that the x positions or x values for the list of points above the vertical center are all within the width of the most extreme x points for the points that are below the vertical center. So in this case, we have these green check marks here because they all passed. So we would consider this to be a shape that's pointing up. These next two here would not be shapes that are pointing up. So here we have our left and rightmost x points below the vertical center, and as you can see, we have 3 points here with these red x's that are outside of that. So this would not be pointing up, and indeed, if you look at the shape overall, it appears to be pointing down. And then something that's more or less sort of a diamond or slightly tilted square shape, for example, how the sign was, the road construction sign in that first image that we looked at, that would also not pass because you're going to have 2 below here, and then one of these points will be within the width that we're allowing, but one will be outside of it. So that's essentially the logic of how we can tell if a convex hull is a shape that's pointing up. So we've gone through the documentation at this point, so let's go ahead and build the project. So we're going to go to C and Visual Studio 2013 Progs, Visual Basic, and I'm going to take traffic cone detection. That's the one we took a look at earlier that's already done. And actually, before I move it somewhere, I'm just going to copy and paste the name to eliminate any typos when we type it back into Visual Studio. Okay, traffic cone detection, move there, and it's now no longer here. I'm going to move this over to the other screen and fire up Visual Studio, and we'll recreate the project. So if we go to File, New, Project, And Visual Basic Windows Forms application. I'm just going to paste the same name that copied a moment ago there, traffic cone detection, and we're going to save it to C, Visual Studio 2013 Progs Visual Basic. And here it is, so you can see it appear over here. Create directory for solution unchecked, add solution to source control. It's unchecked, choose OK, and there we go. This is the one that we just made at this time. You can see there's almost nothing in there. And now I'm going to minimize this, and we'll go ahead and bring up installation cheat sheet 3. And this is from the repository and video earlier covering MGU installation and configuration. Please see that if you have not already. I'm just going to swing this over to the other screen here and then follow the steps in the installation cheat sheet. So let's rename the form first. So rename, yes, let's update all references, save, and now we're going to go to project, add reference, and then browse, and we're going to choose those files and add, and then OK, and then we're going to go to project and add existing item, and then we're going to go to C, MGU Windows Universal CUDA 2410 bin x86. We're going to show all, and then we're going to highlight those, and then we're going to choose add and give Visual Studio just a second to add those. Okay, go ahead and save it. Then we're going to highlight all the DLLs, and we're going to bring up properties, and we're going to go to copy to output directory, copy always, and then save. And now we're ready to build our form. So let's minimize this, and then we'll go to form design.png. So we'll use this as our cheat sheet. Just move it over to the other window here and work off of that. So let's see, we got to close properties and then open toolbox, and we're going to go to table layout panel, put one of those here, and then we're going to add a row, add a column, and also add a row, and then edit rows and columns. And just to start with, let's change everything to 50% proportional. It'll change those to 33.33 as soon as we choose OK, so we can just make them 50 to begin with. There we go, they're all proportional. Okay, so we're going to put where our components, let's see, common controls, there we go. We're going to put a button there, and then we're going to put a label there, and then we're going to put a checkbox there. Then we're going to put an MGUCV image box there, and we're going to put a text box there, and then we're going to minimize that and containers, and we're going to, let's see, where's dialogues, there we go. Double click on open file dialog, and now let's bring up our GitHub page again, and let's see, it takes just a second to come up. There we go, traffic cone detection Visual Basic. So here we're going to go to frm-main.vb, and here's the completed program. We could copy and paste out of here, but it's a lot more straightforward if you go to raw and then copy and paste out of here. So the next thing we're going to do is we're going to copy and paste our component names out of the top section here. So table layout panel. Okay, I'm copying and pasting in the left screen here. There we go. Table layout panel, and then we're going to go to properties so we can change the names, and there we go, table layout panel. Then we're going to paste in the button name, button open file, and then the label name, label chosen file, and then the image box name, image box original, and then the text box name, txt info, and just two more, checkbox show steps. We're going to go ahead and paste, whoops, there we go, paste that name in, and open file dialog, open file, there we go. Okay, now let's set some properties. So we'll choose these three along the top here, and then we'll go to anchor, and anchor on the right side, and let's make that font 12, nice and big. And then let's put in some text here. So working off the form design cheat sheet, let's see, the button text should say open file, I believe. Yes, that's it, open, OPEN file E. And the label can be blank, but before we blank that, let's set text align to left. Okay, go ahead and blank the label text. And for the checkbox, we're going to change the text to show steps. And for the image box, we're going to choose, let's see here, column span, set that to 3, and same for the text box, and then for both of those we're going to change dock to fill. Dock and fill. And for the button we're going to change, let's see, auto size. Yes, there we go. Auto size to true, auto size mode to grow and shrink. And what's next? Okay, for the text box we're going to turn word wrap off. And there's a few more properties here. Multi-line, we're going to set that to true. And then we're going to change scroll bars to both. And now we're going to click on the table layout panel and edit rows and columns. And let's see what we can change here. So for columns, we'd like to change the column with the button to auto size, and also the column with the checkbox to auto size. And that's going to make the label fill up the rest of the space. That's good. Okay, now we're going to go to edit rows and columns, and we're going to go to rows. And row 1 we're going to make auto size. That'll make it as small as possible. And then in this particular program there's not much to show with the text box at the bottom, so let's just make that take up 15%, and then we'll make the row with the image box take up the remaining 85%. Okay, that's good. Now let's make sure that we have the table layout panel highlighted, which I believe we do. Actually, on second thought, let's make, well, we're going to make it a little bigger. Yeah, that'll work. At first I was a little concerned that this might not be enough room for the text box at the bottom. Oh, by the way, I just realized I didn't change back to the large cursor. I'm going to pause for just a second to do that. Okay, sorry about that. Hopefully those mouse movements weren't too hard to follow with the smaller cursor there. So at this point we're going to highlight the table layout panel, and then we're going to go to dock and fill and save, and we can go ahead and run our program and just test to make sure that the form appears how we'd like. Everything should auto size and reposition automatically. We can drag it up to the top to maximize it if we like. Okay, that's good. The only change I would say is maybe let's just make it a little bigger, and I just realized I forgot to set the font for the text box as well. So let's set that to 12 and then Courier New. Okay, and then let's make the form a little bigger, maybe about like that would be good, and save, and let's run it. And that's much better for a default size, maybe even just a little bigger than that still. So we can drag that down just a tad more, and there we go. And let's run it one more time, and that looks good for our form. Okay, next we're ready to add the click event for the button. So let's click on the button and make sure we've named it button open file. Yep, that's good. Okay, we can close out of this. Double click on button open file, and that will start to write the button click event for us. Now referring back to the GitHub page, we're still in the raw code here. Just to remind everybody how we got to this screen, if we go back here, so if you go from traffic cone detection Visual Basic to frmain.vb, here you could copy and paste out of here, but that's kind of awkward, so instead go to raw. And now at this point we're basically just going to copy all the way down and paste everything that isn't in there already. So we can start at the top here with that. There we go, and delete these blank spaces, and then we'll grab this comment line. I feel that improves readability a little bit to see where your functions begin and end. And now we're going to grab the body of button open file underscore click, which isn't that long of a function, and there we go. And I'm just going to make sure I got everything aligned correctly at the beginning. And yep, that looks good. We're getting these underlines because we haven't pasted those functions in yet, so let's do that now. Find traffic cones is the next function, and we can put that here, definitely after the sub but before the end of the class. And let's make sure that came in correctly at the top there. Yes, it did. Okay, still more underlines because we have some more functions to paste in here. So next is convex hull is pointing up, and we'll paste that in right there, and then remove overlapping cones, and that'll go right there, and then draw a green dot at cone center, which will go right there. And then our last function, which is close show steps windows, will go right there. Okay, and you can run either with or without debugging. We'll go ahead and start without debugging. That's going to be a little bit faster, so we'll reposition our form a little bit here, and let's choose some images to test on again here. So one traffic cone was found, and One traffic cone was found and seems to be working just fine. So let's see here, the one with 6. Whoops, okay, I forgot one setting. It's preferable to go to the image box, properties, and then set, let's see, size mode to zoom, and that will zoom the image in and out, but yet maintaining the aspect ratio to fill the available space in the image box. So now if we look at that 6-cone image again, there we go, that's much better. And we can go ahead and show steps and just prove out that that works. And so there's our show steps. There's original, there's HSV, there's thresh low, there's thresh high, there's image thresh, which is low and high logical ORed. Then we have smooth, then we have canny, then we have contours, then we have all convex holes, and then convex holes 3 to 10, and then the next step is going to isolate out, you'll recall, only the cone that's pointing up, so that's going to clear out all this other stuff. And there we go, there's image traffic cones, there's no overlapping ones, so this one's going to be the same. And then we simply draw that on our final image. And I did just realize one more setting here. If you leave the image box enabled, you can crop out, or I shouldn't say crop out, you can zoom in on portions of the image. Sometimes that happens unintentionally. For example, I really didn't intend to do that there at first, so if you go to the image box, and then you go to enabled and set that to false, then now when you click on an image it won't let you zoom in on it, which usually is a better thing because most of the time you don't really want to zoom in on it. So there we go, now we can't accidentally zoom in on it. So to just sort of wrap up the video here, we'll take a real quick shoot through the code. Most of it's pretty self-explanatory. Of course, I always try to write code with variable names and comments and so on that makes it really easy to follow. The first function here is the button open file click function. This really just handles the button click event here. This part here is simply reading in the image and error checking it. Here we update the label on the form. Here is where we call find traffic cones, and that gives us our list of traffic cones. And next we copy the original image here using the clone function into image original with cones so that we don't have to draw on the original, so that we can show the original image in the show steps function completely unaltered. And then we draw the location of the cone and then the green dot on image original with cones, and then this part here is simply updating the text box at the bottom of the program. Then here we update the image box, and this is the function here that does most of the work, find traffic cones. So we close show steps, we call this function here close show steps windows, and that's this one way at the end that simply closes any of the show steps windows that may have been open from a previous time that this function find traffic cones was called. Here we declare our images, and then here we declare our 3 lists. And from this point on, it's pretty much just going through the steps one for one, matching what we took a look at earlier in this document here, steps with images. So I'll leave that for you to read through the code if you'd like. Again, it's pretty self-documenting and pretty self-explanatory. And then at the end here, if the checkbox is checked, of course, then we show all the show steps images. And we have some other helper functions here. Here's the convex hole is pointing up function. We had that slide to kind of go over some of the details of this earlier. And then this is the remove inner overlapping cones function. And then the draw a green dot at center at a cone center function. So that completes the program. If anybody out there was searching for this video name or similar specifically to detect traffic cones, hopefully this was very helpful. Moreover, many of the steps that we applied today to detect traffic cones in an image could be applied to detect all types of different objects in an image with OpenCV. So I hope that a broad audience of OpenCV users out there may find this video helpful to them. As far as future videos, I'm definitely thinking about jumping into the Raspberry Pi 2 with OpenCV in the relatively near future, maybe even for next video. I'm not really sure about that yet. Also bouncing around some other ideas as well. If anybody has some ideas or particular feelings one way or the other, please feel free to post in the comments below. Also, if you found this video and the GitHub repository or any of my other videos in GitHub repositories helpful, please consider supporting me on Patreon. I would very much appreciate it. And also please feel free to rate and subscribe, and I'll see everybody in the next one.